Awesome. Perfect. Welcome to this webinar about speaker design for warehouses and open space. Just covering a warehouse and open space probably would be done in 5 or 10 minutes, depending on the experience, of course. I will go through the agenda very quickly. I first introduce myself. So I'm a FHIR and PAVI solution architect. The basic I design systems, verify project details, help in tendering processes, do acoustic simulations, and very experienced electroacoustic engineer. The background is over 11 years. I worked in that area nearly 15 years and partly involved in business development, sales, product management. As you can hear, maybe from the accent, I'm not fully Australian, German, and I worked in both countries so far. So let's go through the agenda when it pops up. That's interesting. I know the agenda. We cover why PAVI, so I introduce you to why do we need actually voice alarm and a loudspeaker and something that you understand. Describe acoustics generally, so the basics. I cover our speaker range, and then I go into specific example how you could design a warehouse, talk about sound pressure level, and we do a calculation, how to calculate a sound pressure level. And then we go on and look at an open space and explaining some of our speaker ranges or speakers you can use for open space areas. So what do we do? Honeywell in general, well, we offer products. We offer also support in proposals or budgetary costing, sales or technical training. We consult, we do webinars, and give constant updates on standard changes for the Australian market. So I'll jump straight into the presentation. So why public address and a voice alarm? And I start with a little video, which starts right now. And I will say something to it. Can you see the video? Normally, you should see the video. Okay.
Yeah, the video is starting. Yep.
Yes, you see the video? We just tested it a half an hour, but live, yeah. But okay, I can see the video. Wonderful. Okay, I know the video, so I don't need to see it. You see a basic scenario running right now where you have just fire detection and maybe some strobes installed, but no voice. So people running around in panic, don't know where to go, have no visualization or emergency lighting. So it's very confusing. And roughly by now, you see that the evacuation failed because of no voice alarm system in place. Now we look very soon or around that in an optimized scenario. That means you still have fire detection, but you include speakers throughout the site. In this instance, I think it's a shopping center, and combine it with emergency lighting if you want to. Probably you need to. And the main difference, of course, is now you hear announcements through either a sounder integrated in the fire detector, plus the speaker that comes from the voice alarm system, which can be used for many various purposes, and also, of course, different languages applies to it. And then you have some visualization via the emergency lighting. So overall, that's the scenario you actually want to announce or gives people the confidence where to go, and you avoid panic situations. Because I can't see the video, I don't know where we at. I just move on with the next slide. And I summarize basically the outcome from the video you just seen. So all in all, a PAV system offers the ability to inform occupants and you coordinate a response to an emergency or change situation. So there can be a fire or a shooter or anything which happening in the building. The main advantages are you reduce the evacuation time, you avoid panic situations. A proper PA system makes just a sound difference. So digital system, and of course using the right type and speaker and location, and you produce with that clearer messaging. Important, intelligibility, correct design, and compliance to standards. So this is a very important part, intelligibility, which comes throughout the whole presentation, why that's so important. So it has to do with acoustics, ambient noise, location, types of speakers. You need to have knowledge about the PA system you actually design, or you get help from the manufacturer. And of course, you need to understand the standards in form of planning, engineering, installation, operation, and of course commissioning. Partly that's of course more for integrators, but if consultants know that, that's also quite an advantage. So all in all, you need to have a compliance system in place to fulfill the voice alarm system. So to do a SPL calculation or understand generally intelligibility, why it's so important to use the right speaker for specific location scenarios, we need to cover a bit of acoustic principles. So I start off with the hearing threshold. We humans hear between 16 hertz and 16 kilohertz. Some refer to 20 hertz to 20 kilohertz. And as younger you are, as more higher frequencies you can hear. As older you get, as less higher frequencies you hear. But what is a low frequency? Low frequency comes with a long wavelength, and you have a big speaker. So that's called the bass speaker. When you have high frequencies, they're very short in wavelength, and the speaker is normally small. So frequencies come and with propagation of sound in different wavelengths. What does it mean for your hearing? Because we hear always in the frequency range. We have specific areas we hear very good speech, and we have really good music. So the dark blue one symbolizes basically for speech, and where you hear really good and really best is between 500 and 4 kilohertz. So all below and above is not really, the ear can't really adapt very well. It hears, but the focus is on that frequency range. And for music, it's a much larger and wider spectra. So for music, you won't actually have a bit reverb time and just a bit more volume in a side. So why sound pressure level, or how is that indicated? So when you have frequencies and propagation of sound, that comes with pressure. So how we hear the ear filters that with pressure, and so all sound related levels are signalized with sound pressure level. And in standards you see dBA, so dB, decibel, in brackets A, and A stands for the relevated curve for the human ear. So it's basically an adapted curve for our hearing spectrum. When we talk about sound pressure level, we can have a reduction in sound pressure level when we go away from the sound source. So when you stand in front of the concert stage, it's very loud. When you go away 20 meters, it's less loud. That's very simple. But when you calculate that, it comes with doubling the distance, you decrease the sound pressure level by 6 decibel. That means you have a sound source, and 2 meters away, you have minus 6 decibel already. And 2 meters more, so doubling, with around 4 meters from the sound source, it's minus 12. So in a rough indication, 10 meters decreases your sound pressure level by 20 decibel. With reduction, you can also have an increase in sound pressure level that comes with power. So as more power the speaker has, as more sound pressure level you gain. There's also correlation with doubling. So by doubling watt, you increase the sound pressure level by 3 decibel. So example, 1 watt, 93 decibel, 2 watt, 3 decibel more. Another factor which you need to consider is when you have several sound sources. So you have an area of 200 square meters and you install 6 speakers, the superposition of sound waves. So each of these speakers propagates sound, produce reflections, and because of these reflections in a room, you gain another 3 decibel. So a lot of people refer to, let's install more speakers in an area and then you make it louder. No, you don't, because it doesn't matter how many speakers you have in an area. You always only gain 3 decibel more. That's the superposition of sound waves. You only gain more sound pressure level in an area if you use a speaker with more power. So, important, very important, the next 3 slides about reaching STIs and intelligibility. When sound propagates, you have reflections, absorption in a room, or diffusion. So, reflection is very clear. From a wall, absorption, you absorb the sound, and diffuse is just goes in different direction. So why is that so important? So reflections define the reverberation time in a room. So as more reflections have in a room, and that comes with orders, so let's say 8 orders, the sound gets reflected in a room 8 times. And by your reflections, you generate your reverberation time. So basically it means less reflection, less reverberation time. It's important because in a room you can also have absorption. So that means if you have an area or one surface in a room which is really high absorbent, you reduce the reverb time enormously. So let's hear an empty room, which is very reverberant.
In a very reverberant room.
Again, I can't hear it. it should be over by now. So as you heard, that room was really reverberant and you couldn't really understand the message. It was hearable, but probably when you measure the STI, the speech transmission index, probably fail. By just putting
In the
carpet
same room after carpet has been applied to
you
the
hear
floor.
a very different message, basically the same. It's still reverberant, but you understood it clearer by just putting one carpet in one area. So what does it mean? Factors for intelligibility. The acoustics of a room, sound reflections. How loud is it in a room? Reverb. That is defined by type and size of the room. And as more absorption materials you can enter or have in a room, as better your reverberation time and your intelligibility. So all then comes down to revision of your design, especially when you have a large area or an airport or a metro station or a large entrance hall of a shopping center, museums, everywhere where it gets kind of critical because of hard surfaces. You need to work with absorbing materials and look at the acoustics. So that also applies, of course, for a warehouse or a car park. So the type of speaker, the spacing between speakers, and of course the sound pressure level you gain by a speaker is important. If something is installed and you still have problems reaching the sound or speech intelligibility, you can apply equalizing. That means you cut off frequencies, you cut out any disturbant frequencies in the frequency band in an area, which could increase your speech intelligibility. So let's have a look into 100 voltage speakers, which you can use for voice alarm systems in Australia. So within our range, we have several speakers like wall mount, ceiling, column, projection, and horn speakers. And they all come with different wattage. So as higher the wattage, as we just learned, as higher the sound pressure level. So, and of course, you can also have public address speakers. That means they're not certified. Comes with a wider range of speakers, for example, a pendant speaker, and but similar to understand a message or have a good experience of music, you need to always look into what or which speaker you're going to choose for the specific location and how is my acoustic background. So that brings me to speaker design for warehouses. But before we do an example of sound pressure level calculation and how you can place your speakers and what is important to know, we look into the standards. Because that's important too. Australian Standard 6070 describes fire detection, warning control, and intercom systems. So for system design, installation, commissioning. Part 1 is fire. Part 4, emergency warning and intercom system. And people can sometimes misunderstand 6070 versus equipment standards. Equipment standards describe the system you use, which needs to be certified too. And at the moment, 6070 describes 3 equipment standards. Of course, more, but related to audio and PA systems or voice alarm systems. Australian Standard 6849, it's for sound systems. 20-20, the emergency warning intercom system, so the EVIS system. And 4428-16, the emergency warning control and indicating equipment. But what's the difference? So I tried to put that down into a table. So again, 6070, the standard you need to comply generally, especially about design, installation, and commissioning. And 2220 is the old standard for EVIS systems. I think started in the 80s, and I can tell you it's very unique. Nobody else in the world has an EVIS system apart from Australia. So your buttons, alert, evac, PA, and also the VIP system, the emergency intercom system. When you just look at Australia, is unique. You have a similar system in America, but it works a bit differently. You have your manifold call points, and of course your power supply to the system. On 2220, complies everything. So there's a big change. And this standard 4428.16 is already used and will take over 2220. So 2220 will run out by end of 2023, and then 4428 will apply. And the main difference to this standard is that you have grade 1. That's basically the old EVIS system, the audio part and what complies to this, and grade 2 and 3 for occupant warning system. So, but the tests and requirements for the intercom system, many call points and power supply, using a different standard. So it's more related to each individual system needs to comply to a certain standard. But what does it mean for systems who have a certification for 6849? So just the PA system, which has the certification, which we do with 2 of our systems. You have an EVIS front fascia, which complies to 2220, and you use 6849 public address system, you still comply to 6070. Or you have a 4428 front fascia and a 6849 PA system. That also works. So it will be interesting in the next 2 years how that market will develop with this standard change. And before I talk too much about standards, because that can be covered within another hour, I go into the example of a large freight warehouse. So on that XJR, you see that that's really large. I just used a front view. Just imagine when you look at the top that it's 50 meters wide and 50 meters long, or even 100 meters long. And in between you have your shafts or some open spaces. So in the end, the whole area has more or less hard surfaces, and maybe at the top, ceiling, which is absorbent, so acoustic absorbent, or you have all your rows and with material in there, which is also kind of a significant factor for absorbing sound and reflections. That means when you stand in a warehouse and you have a ceiling up to 12 meters, it's when you go in there, you have a feeling of, yeah, that's reverberant. It's uncomfortable. You need to talk louder. So, but that's just because of the larger volume of the building and just the room acoustic applied to this large building. So normally in a warehouse, you only can install speakers up on the ceiling. So in this, for this example, it's around 11 meter 55. In my calculations, I used 11 meter 60, 11 meter 50, 10 centimeters don't play a large role. So when back to the standards very quickly, 6070.4 describes that you need to reach a sound pressure level of 75 decibel and an STI of R largest 0.5 or equals 0.5 at your hearing level. So not on the floor and not at 2 meters, it's around 1.5 meters. So when you measure your SPL and your STI, you need to do that at 1.5 meters. That means you need to reach 85 decibel. So quite loud. And looking at our warehouse, you have 75 decibel, definitely, probably a bit more. Just imagine there's running, some trucks through or people talking loud. You very easily on 80 decibel. So, following questions. Is it possible to reach the sound pressure level of 85 decibel using a horn speaker, which you just seen before on the slides, or a projection speaker? Bit better design, bit better looking, with a bit of tapping. So that means the speaker doesn't come with full power, so you tap it. Then the tapping here in Australia is like 1 watt or even under 1 watt. And I use purposely a bit more, but you will see that in the calculation. And with an installation height of 11 meter 50, 60, and an ambient noise about 75. So just by thinking about it, when it's the loudspeaker's really high at 11 meters, that might be very tricky reaching the sound pressure level on hearing level. So to understand what I actually say with this, I prepared an example how to calculate sound pressure level, and then we look into T2 speaker types. So we assume we have sound pressure level coming from one speaker or several speakers applying to this warehouse of 100 decibel with 10 watt. So this speaker is on full power, 10 watt. We tap it, so we reduce it to 5 watt. That is a reduction of -3 decibel, so a decrease. So half the power, -3 decibel. Doubling the power would increase by 3 decibel, but we reduce it here. And the installation height, 6.5, 11 meters, 50. Hearing level, let's say 160, 150, reduces your sound pressure level by 20 decibel. So you end up with 77 decibel, but because you have multiple speakers in place, superposition of sound waves, you gain another 3 decibel with the tapping of 5 watt. Just as an example. Looking at the standard, you wouldn't comply here. You reach only 80 decibel. So that's just 5 decibel over the ambient noise. Let's look at the 2 different speaker types. A horn speaker comes with a very plain construction. It has normally a cutout in it for higher frequencies, and it's very loud. It's a high-powered speaker for giving a lot of sound pressure. And a projection speaker is a bit more better in design, but normally comes with less power. So let's do the calculation together. The max rated power from our horn speaker has 170 decibel. So that's like an airplane starts off. That's how loud it can get by just standing really next to it. 15 watt. We tap it to 5 watt. 10, 5. So we basically halving and halving again. That reduces the sound pressure level by -6 decibel. And then we have the installation height 11 meter 60s. So another 20 decibel, which reduces the sound pressure level on your hearing level to 91. And because of the several sound sources, you gain another 3 decibel. So you're 19 decibel over the ambient noise of 75. You can tap here to 2.5 watt easily, because that just reduces sound pressure on -3 decibel. If you use the projection speaker of 10 watt, you tap it to 2.5 watt. So again, 2 times reducing the power. And that decreases your decibel by -6. Again, the 10 meters reduces the sound pressure level by 20 decibel. And your superposition sound wave effect increases the decibel, but you only reach around 77 decibel around your hearing level, and you wouldn't comply to the standard. So let's make an example and use the projection speaker on 10 watt. So you don't need to do this calculation. So basically that one kicks out. You decrease by 20 decibel, you're 80 plus 3 decibel, you're on 83 decibel, you still not comply to the standard. So let's make a summary. What is really important if you do a speaker design in warehouse. So first of all, you need to look at the building. What is in there? How does the acoustic look like? How many rows you have? How many people will work in there? Are there machinery running? Are there people driving through with some cars, etc.? So how loud does it get? Ambient noise. How are the room acoustics? So are there any absorbing materials, or do we need absorbing materials to reduce the reverberation time? And very important, where can I install my speaker? On the ceiling, or maybe just on a lower height, like 5 to 6 meters? So that brings you to the requirements on sound pressure level and speech intelligibility. So how do I need to tap my speaker? High, low? How do I install the speaker? And we always recommend installing speakers in one direction. When you install speakers in the same direction, the waves kind of going towards each other, so you have highs and lows, and so you have loss of frequencies or gaining frequencies in areas a lot. That is just confusing for any sound and intelligibility, especially for speech. We also need to look into the spacing of the speaker. So spacing speakers all 20 meters, you won't apply. So just another example of the 10 meter, you reduce the sound pressure level by 20 decibel at just in length of the distance. And of course, from the distance from the height to the bottom. So that wouldn't work in a warehouse. So you need to definitely look into 10 to 10 meter spacing or even less. Where you all check these variables and you think, no, I won't comply to reach the intelligibility of transmission index of 0.5, you can use VADs, visual alarm devices, strobes, but they need to be installed that people can see it. And the standard says if VADs are installed, you don't need to do SDI measurements. But VADs, of course, applying to more costs, installation, and yeah, you, as a consultant also and an integrator, need to verify what is more efficient. In the end, when you decide on using VADs and you don't understand anything in the warehouse, so what's the purpose of having a voice alarm system in place, or which actually has the function of being an emergency warning system? So this is the factor where it comes down to the video you've seen before. You have a message, or yes or no, and if you have one, how good shall I understand it to be warned of an incident or of a fire? So if you have a chance in a warehouse to reduce the installation height, then go for it. Because that would mean you can tap the speaker and also have rather less issues reaching the sound pressure level, which is required to comply to the standard. And as lower the speaker get, on installation height as more direct is the sound. So it's of course better to understand any message. So open space. Open space is a very different area compared to any enclosed, because all what I explained just right now about acoustics in a building doesn't comply, because there are no reflections. So you have an open space, the sound just goes and ends in energy at one point. That applies, of course, to a room too. That's why you have all the reflections in orders until the energy of a sound wave just finishes it. When you look at an outdoor area, like let's say a platform, a metro platform, you need to look how loud is the environment. How loud does it get when the train arrives? So you talk here definitely about 90 decibel when a train arrives, or even more. So it's critical to achieve the intelligibility, speech transmission index, and here it's very important which speaker you use. So when it's centralized and you know, on a platform and you have like a roof and it's just 3 meters high, you normally go with ceiling speakers or column speakers, which are very direct. But as soon you have no ceiling anymore on a platform, and you just an open space and you have only just columns, you need column speakers or full range speakers or any speaker which applies to have sound propagation into a specific narrow field with high power. So to reach SPL and STI in an open space, you need to direct the sound to the people and not just anywhere. High sound pressure is normally required. Again, sound propagation in one direction. So you have 2 poles on a platform. Don't put the speakers towards each other, always in one direction. And of course the spacing. So you have 2 poles in between 10 meters and it's just not enough to install one and then in 20 meters. It's not enough sound pressure you will produce. So what possible speakers you can have, which I just mentioned, some of them: horn speakers, projection speakers, passive or active line arrays, pull-in speakers, and special outdoor speakers. So let's look at some of them. Yeah, that's a high quality passive line arrays. This speaker is called Elene series, and they E54 certified. So as longer a column speaker gets, as better sound propagation is into the verticals. So as longer it gets, as narrower the sound propagation into one direction. Why? What is the effect? As narrow sound propagation gets, as less reflection you produce, because the propagated sound gets reflected in a very narrow space. Very usable in metro stations, airports. Yeah, you can also apply to warehouses, but that could be very cost effective. And museums, yeah, shopping centers, even in schools probably, or audience halls, yeah, sport parks. Not related to any standard are active line arrays, and active means that you have your power in the speaker. So all the DSP amplification is in the area itself. So you need to, when you really use it for voice alarm, need to comply with power supply. But these speakers are available up to 4 meter length. And this specific manufacturer produces 2 beams. So what does it mean? They produces 2 beams in 2 directions. So one in the near field and one in the long field. very effective speakers, usable for, yeah, again, metro train stations where it's large, long, very reverberant. And by the way, when I mentioned reverberation again, all above 2 seconds, very critical to reach STI indexes generally. Let's look at some more speakers. DAS Audio. I mentioned these manufacturers because we're working with them together, so they're partners. And these specific two-way passive point sources are EN54 certified. So they can be cross-listed for the Australian market. And also here, a line array. And these speakers, of course, have high power. So like a sport hall where you really want to have good sound, good quality, good music, but also a high sound pressure level and good or reaching good intelligibility, use full range speakers. That can be applied also for outdoor, of course, or yeah, wherever you want to have just a bit more of quality. And I show you now two specific outdoor application speakers from a company called Hyperspike, also a partner. This is the TCP-A10. It's a very high-powered speaker. And yeah, it can be used, of course, in warehouses or airports, parking structures, parking lots, outdoor areas. I'll give you an example at the end. And this is another one, the TCP-AUL. This comes in round and is, so when you imagine you have, like, again, a warehouse with like 20 speakers installed, this speaker is so much in power and propagates sound in various different locations because of many different speakers allocated in one. You minimize the amount of speakers by maybe 5 or 6 instead of 20. And another series, the Encompass series, you can see how large the speakers are. So that's the human body, and they nearly double or 3 times high. Again, as longer a speaker, as more power you generate, that same accounts to a line array when you're at a concert. Line arrays are huge, large, a lot of power. So let's look at a little video that you can see and hear what I mean. And I can't see it again. So I hope you can hear it. So there's a building, there's the speaker installed, and then it goes away, and then you need to wait a little bit, and you can make your own assumptions how good you understand the message.
We'll conduct a test of the campus emergency broadcast system. This is only a test. If this had been a national emergency, you would have been instructed with news and official information. This concludes this test of the campus emergency broadcast system.
I think the video is over. So yeah, that's it. I would say. So feel free. Over now. Cool. Thank you, Pete. Yeah, as you could say, that distance from the speaker was like 300 meters roughly, and it was really, really loud. So for specific locations, for specific areas, outdoor events where you need public address. So just imagine, no, just remember a project we did with one of the manufacturers you just seen. So the column speakers. You probably all know the Oktoberfest in Munich, and there is actually a public address system installed throughout the whole site when you be at the Oktoberfest, and the speakers are used as a mix of passive and active line arrays. And yeah, that's a really good example for an outdoor application using a mixture of passive and active line arrays. Team chat. So if you don't have any questions, I really hope that the presentation was interesting, and for people who've been very experienced in PA and audio and acoustics, I hope you gain some more knowledge, especially about standards, probably not so much about acoustics and audio. And for people who never sound spheres, how do I understand sound spheres, Tim?
Thanks, Harry. That was very informative. And yeah, thanks for the video and the example provided. We can all hear the video fine. And apologize if there's any connection issue with the video, with the camera. So this concludes the session today. If there's any questions you'd like to ask Harry, there's a Q&A button at the bottom of the screen where you can ask questions, or outside of the webinar you can also raise the questions using the book meeting button. We can always organize some private lunch and learn with you. If you check the speaker bio, Harry's email address is also there, that just for your convenience to reach out to him directly. There's another button called resource list. That's where I have uploaded the presentations for today's slides there that you can always review. And of course, the on-demand session for this webinar will become available after this. And you can always use the login link where you use for joining the webinar to watch the on-demand content.
You
so
mean
how do you feel of the webinar?
The last speakers you've seen in the presentation?
Yeah, that was very powerful. So we have also prepared a survey on the right-hand side of the screen to help us understand how we can do differently in the next time, or if there's any specific topic that you'd like to discuss with us, please let us know.
So sound spheres, you mean maybe pendant speakers? Maybe I'm not getting the English context now. When you mean pendant speaker, yes, of course you can use them because you can hang them down. So, you often see them, for example, in Bunnings. So wherever you have also, again, a large building or high ceiling. So, of course, you can use it in warehouses. Just when in between the rows, you normally have machine and they apply and get all the material out. So installation of pendant speaker is not really useful because you would destroy it. And like supermarkets, you can use pendant speakers. It can be used also partly in stadiums, also partly outdoors. Outdoors, you never forget weather, water, rain. So you need to have kind of an IP standard applied to the standard that you don't destroy the speaker due to weather corrosions. Also, is a length of time until you can use a speaker. Does that answer your question? I hope I understood it. Okay, thanks. Yeah, pendants. By the way, we're working on a certified pendant speaker at the moment. So that would be then unique for the Australian market, having one for certified for Australian standards. So let's look. So Wow, that's hard to answer because reaching intelligibility always depends on type of the room and the acoustics to it. So wherever you have, I give an example in form of, you have hard surfaces. Let's go into a car park. It's concrete everywhere. And you have some cars standing around, they're a bit absorbent. And here advice would be, look for direct sound or wherever it's possible, absorbing material, because a car park enclosed, of course, it's very hard to reach intelligibility by just applying some speakers in there because of just the room acoustics itself. It's hard to reach. When you look into an office, normally carpet, normally you have curtains on the wall, you have a lot of desks, some plants, computers, shelves. So you don't have really reverb time. So advice here, go for ceiling speakers, you normally comply. So look at a metro station. Train arrives, very high sound pressure level. So you need to work with automatic volume control. That means by arriving of the train, the sound pressure level gets automatic increased. So, and depending on the area, you use just standard 100 voltage speakers or very specific high quality speakers, which propagate your sound differently. Or you use four-range speakers where you need to have high power, like outdoor applications or sport arena or stadium. So main advice is verify the room acoustics. When you know from the beginning that will be a very difficult area because of hard surfaces and high reverberation time, high reflections, and you're unsure, contact our acoustic consultants, reach out to us, and we can look into the area and give you advice what to do next. And with that knowledge, you can then go and use your speakers for the area. So I often see it the other way around. They design speakers and then afterwards worry about the acoustics, but that's sometimes too late. So, but for major project, normally that's included. So it's just that's the basic advice, I would say. Room acoustics first, then the speakers. Did it answer your question, Chris? Where you have, well, two ways. One, apply passive acoustics. So passive acoustic means you use absorbing material. For example, in a car park, you can use just a very soft fire rated, like foam, which back in Germany we used it quite a lot, and not too expensive, and you reached SPL and STI all the time. Some builders don't want to do that. Then you go back and to the exemptions which are described in Australian Standard 6070. So using VETs, that's the exemption, basically.